Welcome to the Weekly Squeak. If this is your first time with me, I am Christian Schiller, and I always present a roundup of things that have interested me from the past week, of a sort of geeky persuasion, often technology, some other things. We have a few other things this time round, and then quite often I have an interview with someone. And this episode, we do have an interview. We are speaking with Fluree, a blockchain database that packs a lot in, and you can hear some more of that in a few minutes once I get over my weekly links. So let's get started with that. First up was an article on Engadget from Nick Summers on KaiOS. This operating system you may or may not have heard of, depending where you live. It's actually come out of the ashes of Firefox OS from mobile phones. I still have a Mozilla Firefox OS phone lying around. I don't really know what to do with it. It was a bold move. Mozilla tried to create a sort of HTML mostly based operating system for low-end phones for the developing world. It was a bold idea. I must admit I was never greatly impressed with it. It didn't cache very well. It was actually quite network heavy, which somewhat countered the point. And of course, whenever you try to build an operating system, you are reliant on getting developers to build applications, and I think they struggled. But it did not die. Some of the code, some of the developers, and definitely the ideas continued in KaiOS, which ironically has received a lot of funding from Google. So they kind of have the top spot, as well as now reported in this article, the number 3 spot beneath iOS, which is quite interesting. It's used a lot on so-called dumb phones, which I sort of hate that word, but non-smartphones. Although the definition between smart and in quote marks dumb is a little blurry. If you have applications and internet access and etc., is that a dumb phone? Is that a smartphone? I'm not 100% sure. But KaiOS actually has a lot more than you may think. I guess I think of it almost as a successor to something like Symbian as well, maybe, filling that gap in devices. So it's now running on 80 million devices, which isn't huge, but it's significant, and it's growing quite rapidly, and is seeing great success in countries like India and Brazil right now. Companies like Alcatel have released devices. I remember having an Alcatel mobile, actually. You don't see them so much in Europe, certain parts of Europe anymore. I'm not sure about the US. And the main device right now is made by, in collaboration with Jio, a mobile network in India. And they have the Jio phone, which is it's a quite nice looking phone, sort of small handheld, hand-sized device. 2.4-inch display, which gives you a rough idea of the type of phone this is, and 512 megabytes of RAM, basically given away with plans, which is sort of how smartphones as they were then used to be. I don't know if KaiOS is open source, but the company behind KaiOS, which is a company called TCL, is also working with HMD Global, aka Nokia now with the Nokia phones, to build some devices for them too. They've also managed to get a reasonable amount of applications that day-to-day people will need, things like Facebook, Twitter, and Google applications, which is interesting to see that Google are not opposed to always being everywhere, even if it's not on their operating system of choice. And this includes recently Google Assistant, which is interesting too, to have a smart assistant on these low-end devices that can obviously open up a lot more power in other places. And they recently announced $22 million in funding led by Google, which again is kind of interesting. I always liken it to cigarette companies selling Nicorette patches, for example, just to kind of catch everybody everywhere, no matter what they do or where they go. You still have a hold on them. And also, another aspect I found interesting that TCL and KaiOS have worked with Doro, who I have met before. This is an English company who makes phones designed for elderly and disabled people with large screens, large buttons, etc. So I guess, I'm not sure what they were doing in the past. Maybe they were licensing Android, maybe they had their own operating system. So it also helps companies like that who are building specialty devices to give them kind of the bare bones they need to get their devices out. And behind all this, the company has about 260 employees and is leading more funding rounds. So maybe ClaroOS is set to stay and set to grow. And that remains to be seen. So if you are looking for a cheaper device, maybe have a look for that on your next device, if you can find one in your country, of course. Next up, more Mozilla news, actually, or Mozilla-related news, I should say. This is Mozilla's Common Voice project, the project where they're aiming to get a wide and diverse community-contributed set of voice data for use with text-to-speech, with assistants, things like this, to allow for a more diverse set of data for people to use. Let me see. 1,361 hours of audio recorded, with just over 1,000 of that validated in 18 languages. 42,000 contributors have all added their voice. I've been meaning to do it myself, but I keep forgetting. Bad, Chris. And they have languages you would expect: English, French, German, and Mandarin Chinese, but also more obscure languages like Welsh and Cabler. I'm not sure. I've never actually heard of that, so I don't know how to pronounce it. So I guess also preserving some of these languages that may or may not be with us for the indefinite future. So keeping records of them too. I don't think the dataset is available quite yet, but will be soon, it says, on the Common Voice website. Next, an article from Stephen J. Vaughan Nichols on ZDNet. ZDNet. I always just going to do it the way I feel comfortable. The continuing saga of a handful of open source software vendors battle against the cloud providers, or to be more precise, mostly AWS. This is a fairly damning post, or a fairly damning... No, I get this right. A report on a fairly damning statement from Michael Howard, the MariaDB CEO, who is adding himself to this pool of open source projects who have been damning AWS. And he accuses large cloud vendors of strip mining open source. He mentions aspects like cloud providers intentionally restricting self-installed versions of their software on their services, so people have no choice but to go with the vendor's equivalents. He has actual charts here to show how AWS's default MariaDB instances perform poorly, while their own kind of equivalent, Aurora, does much better, but their own kind of tests don't necessarily show the same. This is all very hard to prove, of course. He accuses them of misconfiguring things intentionally to manufacture this poor performance. But at the same time, he kind of says, well, we're just looking to compete directly with companies like Oracle, and we won't worry too much about the cloud providers right now, because I think this is always the problem that a lot of these suppliers have, is that despite maybe nefarious practices, these big cloud providers are still giving these companies a lot of business that maybe they wouldn't have. There's always this interesting compromise of when you do deals with your potential rivals, how much do you give them, because they can help you, but at a certain point they might start hindering you. And at the moment, I guess the balance is just about on the edge. So we shall see how these companies may change what they do in the near future. Next, I am going to cover two articles on money or finance. So, people may know that I have been something of a blockchain fan. My enthusiasm rises and wanes depending on what's going on. But we all know that mainstream adoption has been slow so far, especially on the kind of big killer use cases, decentralized finance or token economy, as it were. Recently, HTC and Samsung both have announced hardware wallet phones. HTC's has been dismissed as a bit of a gimmick. Samsung's, I think, forthcoming device, or just recently released, is potentially more applicable, and they have such a large user base that this could be an interesting jumpstart that the ecosystem needs. But also, apparently behind closed doors, Facebook, Messenger, and Telegram have both been experimenting with this too. I think Telegram been more public with their experiments, already touting the name of the token, the Gram, which is actually not a bad name, and claim to be 90% done already. And I do recall Telegram had their own form of ICO and did very well out of it. And Telegram is already very popular in the blockchain space and the kind of decentralized internet fans space. So they will probably have a reasonable degree of success with that token. But of course, it remains to be seen whether that gets it out of a niche and into the mainstream, if it's just those people who are already kind of part of this doing that. Facebook, more interestingly, unsurprisingly, has been fairly private about what they're working on. Apparently, according to this article on the New York Times from Nathaniel Popper and Mike Isaac, the developers on this project have been working in sealed rooms, which I find a little extreme. And Facebook is a very centralized service, so whether decentralization fans kind of accept this remains to be seen. I hazard a guess they will be very skeptical of it, but at the same time, Facebook is the perfect company to get the concept into the mainstream and into the masses. The question would remain, why do they need to use this token as opposed to standard credit card payments, etc.? Maybe it's a token that's only useful on their platform. Who knows? We shall see. But sometimes, and I have noticed this many times and mentioned this many times, sometimes a community gets its success from the most unlikely places. And it's up to the members of those community whether they accept that or dislike it, of course. And I would imagine that the decentralized community and Facebook are going to have an interesting relationship if this continues. In other news, this is an article on Quartz from, I have to figure out how to pronounce his name, John, that's easy. John Detritixi, I think. We'll go for something like that. I do apologise for any mispronunciations. On the UK is going cashless, and like many other countries who are, they don't know what to do next. I currently live in Germany, which is still very cash heavy, almost to comical levels sometimes, but I know there are other countries in Europe who have almost the complete opposite. Scandinavian countries especially, but also the UK, where tapping to pay with contactless payments with a card or with a phone is so acceptable. You're quite surprised when you find a place that doesn't support it, and you're quite surprised when you see people using cash. This has some positives. It's obviously less infrastructure involved, less direct money-related crime because there's nothing per se to steal from people. Obviously, there is credit card fraud, but it's a little different in the nature of the crime, shall we say. In the long run, it can actually potentially be cheaper for vendors. Obviously, there's a charge that they sometimes are charged for, but I think at the economies of scale, it can work out better value. And at the moment, card payments are actually the majority in the UK. Only 30% now are using cash, expected to drop to about 10% in the coming years. This also has led to negatives, of course, bank branches closing down, even ATMs closing down if they're not needed so much anymore. And it's led to a raft of fintech startups in London, which is not new for London, but they can embrace this trend. The extreme example of this right now is, of course, a country like Sweden, where apparently banks don't even take cash anymore. The interesting societal impacts of this are where the article starts to focus in the second half. Things like, this has always fascinated me, people who ask for money on the streets, what happens with them now? There's someone going to create a budget phone application for people to take donations? People who have no access to bank accounts, which is still a big deal. How do they get cards? And if it's hard for them to get cash, how do they get what they need to buy what they need? And then there's, of course, the whole issue around centralization, around privacy, et cetera, which is the one big issue that tends to get overlooked. Your financial transactions are literally being tracked all the time when you use a card, which is the trade-off for the convenience, I guess. Interesting times. It won't happen anytime soon here in Germany, but I watch from afar at other countries to see how they cope with this transition in the long run. On the subject of Germany and Berlin, where I live, not a tech article at all. This is an article on CityLab from Fergus O'Sullivan about what the city of Berlin is attempting to do around rising rents, which are happening right now. Berlin is still relatively affordable in comparison to other Western European capitals, but that is fast changing. But Germany is not afraid of regulating and stomping over corporates to get the city they want, which is what this article is interestingly about. The city is about to impose limits on how many properties companies can own. And the number is quite high, actually. And this may seem strange to people who live in countries where renting is not the norm. But in a lot of Central European countries, this is more the norm. Hardly anybody owns their own property. So there are lots of sort of what other countries may think of as mega landlords. But the city of Berlin considers mega, and maybe what other people in other countries consider mega, as different. This basically mean that one company can't come and buy up half the city and then really very strongly dictate what prices will be. So actually councils get the last say in this. And a lot of the local councils here have been buying back property, which is a trend you do not see very much in cities these days, to kind of shake up that distribution of ownership, I guess, and make sure that at the very least there's a certain section of housing that is still affordable for some people. And because of this process, the prices have managed to stay reasonable. I think it still remains to be seen how this works out in the long run. I guess, unfortunately, the rising prices are blamed a lot on foreigners, people like me. I think that's a little unfair because it's people who take advantage of foreigners, not necessarily foreigners' fault. Often people arrive not knowing of these sort of rental limits, the rights they're entitled to, the things they can do to change it, etc. And they need to find somewhere. It's getting harder to find somewhere, so you take what you can find. You are taken disadvantage of. When there is a supply and demand differentiation, there's always going to be someone who's willing to take advantage of that on all sides. So it's hard to counter that kind of thing. You also have things like sublets and short-term lets and things like that don't always fit into these regulations, which can sort of circumvent some of these regulations too. But it's interesting to see a modern city attempting very strongly to do something about this problem that is happening in so many cities and putting, I guess, people before profit. Some would argue they haven't done enough, but, compared to other cities, it's quite a refreshing outlook to see. And again, I will very closely this time watch how this develops. And finally, if you've listened to the show before, you know I love maps. So here's a great article on Latham's Quarterly, I think that's how you pronounce it, The Geography of the Odyssey, from Elizabeth Della Zazera. This reminded me, I've read recently books on I have to try and pick the right terms here, the discovery by Europeans of America. Also, the book of Marco Polo's voyages, and these kind of old journeys where people try to map where they were because they can be a bit unclear. And more so in a semi-fictional story, of course. The Odyssey, no one's even really sure who wrote it, who Homer was, when it was written. And of course, it's interesting because a book like that is so epic for the time and makes, journeys that to us now would be a hour-long EasyJet flight. But in those days were big, epic journeys that took a long time over land, over sea. They were dangerous, they were risky. So, most of it is just around the Mediterranean basin still. And the continued efforts of people to map these journeys in the Odyssey and what they mean in the modern world. And this has seen many different results. You can see some great images in the article here about people's attempts at this. And I guess each attempt builds on the next attempt because someone chronicling this in medieval times would have an idea maybe of the places they're referring to, whereas someone now wouldn't necessarily know, but you have to look at the more recent source to try and fill in those gaps. It's difficult because some of it doesn't quite make sense. Some of the distances and times don't make sense. It's not even 100% sure if some of the places even were real. But it's interesting that many people still attempt to do this. There have been many, many attempts, not just in the Odyssey, to map these journeys. And it's quite fascinating. I love maps. I love historical maps, and sort of semi-fictional historical maps are even better. And there's a great interactive map on this article that you can play with in the attempts to at least recreate the voyages in the Odyssey. That was my links for the week, and now I have an interview with Brian from Fluree, the intriguing blockchain database. I have to apologize for this interview. I was recording this whilst I was on the road. I was on my internal microphone in my laptop. He was using a phone, so it really is not the best quality. I toyed with the idea of not actually including it at all, but I wanted to because it was an interesting product, and I'd like to hear your opinions on what you think about it. I will be doing a road test of the Fluree database soon. So yeah, I do apologize for the sound quality. I did the best I could to clean it up, but I hope you enjoy.
I'm Brian Platz, and I am the co-CEO of Fluree, and the other co-CEO is Flip Filipowski, and we've been building enterprise software companies together for about 2 decades now, and even longer separately. And we've built a number of companies that have grown pretty substantially in that space. We've had 2 IPOs in the time frame. One of the companies was the 8th largest in the world, largest cash sale of a software company ever. And it's always dealt in the enterprise software space. So that's really our background. The technology that we build and think about tends to come from that perspective. But certainly things like Fluree aren't exclusive to enterprise software. It's just those are the problems that are kind of front and center as we build. So Fluree, we started almost 4 years ago now. Really, the first 3 years were primarily just in the garage sort of R&D effort. And it was focused on creating a new type of data platform for modern applications. And of course, the last decades that we've been building enterprise software, a lot of things have changed. You know, like we didn't have the internet when we started, and now software is mostly delivered via SaaS. But interestingly, the database technologies that we use to underpin every application we even build today are roughly the same as they were 30 years ago. So it hasn't evolved a lot yet. I think the role of data in applications, the importance of data in applications, how we leverage data in applications. You know, it used to be you built an app and the only thing that talked to the database was the app you just built on top of it. But now we have data stores that have a bunch of apps talking to it, and not just other apps. We have other parties that need access to that data or need to share in that information. But we're still kind of using a technology from quite some time ago to try and facilitate this. And we're building APIs or all this other tech to accommodate our modern needs, as that fundamental tool hasn't really changed. So that's kind of the genesis of Fluree and some of the problems we set out to solve because we struggled with these issues ourselves.
And so I've actually worked a little bit in the distributed database space and also the blockchain space. So you're promising quite a lot with the product. So let's dig a little bit into the technical side of what you have here and what you're merging, and I guess fundamentally and most importantly, why.
Sure. So I guess I'll start out with kind of the structure of what Fluree is and how it differs from what we think of a traditional database, and then we can go from there to get into further details. So the first thing we did with Fluree is we focused on separating out the 2 primary roles that databases play, which is updating or mutating information, and then, of course, querying or asking questions about it. And these are always served in any database you're used to using by the same process. And one of the things we wanted to do was decouple that. So we have two components that we refer to. One is our Fluree DL, the distributed ledger component, whose role is to really just handle data mutations and data updates. It's not there to serve queries or anything like that. You can run it on the same server as a query server, but the query server is designed to scale completely independently and linearly. So you can scale up your reads to really any level you want. Part of how we wanted to mutate data is we didn't want to mutate data. We wanted an immutable database. And certainly concepts of blockchain fold into here, and append-only logs and lots of sort of different pieces come into play. But it all amounts to the fact that today's technology makes it inexpensive for us to store a history of how data has changed over time. So we should just be going to that by default. You know, might cost you an extra few dollars a year because you have every single piece of data that was ever there, but we're starting to do this all the time now, even with things like source code repository, et cetera. We should just be doing this with how we manage and store data. So the Fluree DL part is responsible for running the rules that govern under what conditions data can change. And ultimately, if those rules are passed, they're successful. And we use concepts we call smart functions, and we use cryptography and a bunch of stuff to determine if those rules pass. But ultimately, if they pass, the output of the distributed ledger is basically an append-only log file of the deltas, the changes to the database. But we output it in a format called RDF. RDF is a standardized data format by World Wide Web Consortium. And it's a fantastically versatile data format because you can easily take RDF data, make it look like a relational database, make it look like a document database, kind of read it as an event log, or in our case, we pull it off and turn it into a graph database. And that's really the separation there, is that the abstraction in between is this RDF append-only log of changes that are happening. We represent them as blocks, like a blockchain, because they have all the characteristics of a blockchain. And FlureeDB picks that up and turns it into not only a graph database, but a time-traveling graph database. So because we always knew we'd have the history of all the changes locked up in an immutable, tamper-resistant blockchain, we said the way we index information has to not only understand the data it's indexing like a normal database, but it also has to understand time equally well. And that's a lot of the magic of our query engine, is that when you issue queries, you're actually always issuing a query against an immutable version of the database, and you can execute it against every single version, every single millisecond that ever existed, and get instantaneous responses with Fluree. And of course, if you don't specify the version of the database you want to query against, we do act like a kind of a normal database would. We just pick the latest version we know about, so you're getting the current information. But we really treat the database at this layer like a variable you can pass around in your code. And it just starts to eliminate all kinds of race conditions or integration issues, a lot of different problems that we deal with in enterprise software. Having an immutable database that can never change underneath you starts to solve. So those are kind of the main components, and those are the primary functions of the Fluree distributed ledger and the FlureeDB part.
And this is obviously a question that gets asked a lot in the blockchain space. So I'm going to ask it here as well. It's not impossible to have immutable databases without a blockchain. So why add that complexity?
Well, I don't necessarily think of it as that much complexity. You know, blockchains are a combination of technologies we've been using in some form or another since, the 80s or 90s. So it's not like these are, it's the combination of these things to accomplish things we didn't think about accomplishing before that's really the special sauce, I think. It's not that cryptography or hashing or any of the things that go into this are really tricky. We think that data, but to answer your question specifically, we think that how we treat data and what we're doing with it has changed quite a bit. I started out saying that. And we, a database, which used to just talk to a single application, is now a database that's maybe being used in a software as a service environment that's hosting hundreds of different customers. Or it's a database you're running inside your own enterprise, but it's doing some sort of integration process. Or it's a data in your enterprise, but it's powering 3 different applications, not just one of them. And if we can actually take the idea of a database and a data repository and turn that into the way that organizations can start working directly with each other and interacting with the database itself, we just eliminated a crap load of abstractions, brittle abstractions that we've been building. Like a huge portion of the APIs that we build are just to move data in and out of databases that we put behind layers of firewalls because we would never trust anyone writing data directly to our database. But the way blockchain, I think, has opened up the possibility in this combination, again, of technologies we've been using for a long time, but this unique combination of them actually opens up a avenue to allow third parties to actually transact data in your database directly using rules that you define in a way that can be done completely secure. We don't really deal with the cryptocurrency side, but I like to bring up the example because if you've been in the database space for a long time, it's sort of a mind bender that we put our databases, again, behind layers of firewalls, right? They can manipulate data, change data so easily. We try and protect them. They are our crown jewels. Yet Bitcoin's effectively a very purpose-specific database, but a database that's existed now for 10 years behind no firewall, and no one's controlling it, and it has never been breached or hashed. And that's just kind of an astounding level of data security that's actually representing out there that's possible. And so organizations, I think, can start working directly with each other more effectively because they're actually sharing a common database that none of them are controlling. Everyone has instant visibility, and everyone can fully trust. And they can build their own apps, their own integrations against their own nodes of this common shared database. And this is happening all the time today, but it's happening because, some vendor over here or company is running SQL Server, some over here is running Oracle, and we got all these different applications and people build APIs to try and do ETL jobs to transfer data back and forth. Why can't they just share the same database if they're trying to work with each other? And I think it opens up a new idea. The other thing is that we don't think, databases are effectively even being used in the model where you have a single data store to your application anymore, which I keep bringing up. But the opposite is true, is that you have an application now that's leveraging a bunch of different data sources. So when we think about query languages like SQL, they were all designed to query a single database. But now we have databases that are being hosted on the web, like Wikidata, that has immensely useful information that maybe I want to join that data with other data that I'm storing, maybe in a supply chain blockchain, which I'm also managing data internally that I want private. And we need to be able to push our query layer into not thinking about a database, but thinking about a collection of data sources that it is simultaneously querying and producing a single result. So to our apps, it looks like it's one database, but we're really pulling data from a bunch of different repositories. And again, this all gets to this line that, we think companies will be not only publishing, every company will have a website like they do today, but they'll actually be publishing databases that are provable, that have a history to it, that people can interact directly with. And we think that change is coming.
So there's a couple of things I want to pick up on there. I'll try to remember them both in appropriate order. So one thing you mentioned there about pulling in data from multiple places. So one of the other aspects that you haven't mentioned yet, because you're also adding a GraphQL component, and which is sort of what GraphQL is somewhat infamous for, is this ability to, I guess, massage multiple data sources into something more cohesive. Is that and in addition to a more traditional REST access, or is it replacing it completely? And is that what you're using the GraphQL endpoints for, to be able to sort of manipulate the various sources into a standard?
Well, we use the GraphQL endpoint because there's a significant and growing ecosystem around tools that use that. And the way we structure our data makes it readily consumable by GraphQL. So it's almost, we're a graph database. GraphQL is actually not really a query language. It's more of an API sort of language, but it fits really, really well with graph databases. Now, GraphQL has a bunch of limitations. So there's a lot of things that Fluree can do that GraphQL doesn't support. Things like infinite recursion, which is possible in graph databases. GraphQL has no concept of that. But because our data aligns so well with GraphQL, that is one of the interfaces we expose and you can use. And again, there'll be a few limitations, things you can't do that Fluree is possible to do, but GraphQL can't do. We have two other ways, and they can all be used simultaneously, two other ways of querying data in Fluree. One is what we call FlureeQL, which is a JSON query interface that roughly mimics the third interface I'm going to talk about in a minute, but it's all database, which is really nice. You can compose queries with your code, instead of trying to compose like these big ugly strings of SQL. You're actually just composing data structures to issue queries. So it's nice to work with in your applications. And of course, because it uses both REST and JSON, it's fairly standardized, so it can be used from any language. And because we developed the interface for it, it can take advantage of every single feature that Fluree has. Things like time travel, et cetera, which we kind of had to hack into the GraphQL interface, the ideas of time travel, because nothing out there supports that. The third interface that we support is Sparkle, and Sparkle is another standard. It was standardized by the World Web Consortium around the semantic web and those ideas. And it really embraces the idea of querying multiple data sources. In fact, Wikidata is fully exposed via Sparkle.
Yeah, I have used it in a Wikidata hackathon. Yeah.
So Sparkle is our most native standard query interface because it has a lot of capabilities that GraphQL can't do. But of course, like I said, GraphQL is a growing community. It's a pretty cool tool, and there's a lot of tools out there, and is easy for us to support.
And then the other thing I'd like to pick up on was you mentioned Bitcoin, which is of course a public ledger, but I'm assuming because you're in the enterprise, then the distributed, especially the blockchain component you're adding, is private ledger. It's not going to be, these are all separate instances of Fluree running their own permissions, modules, and things.
That's correct. At least that's the way it is today. However, there's some interesting hooks in there for the world we see evolving. So one is that we have a pluggable consensus model in the code. Now, of course, right now we have not yet open sourced Fluree. We will be open sourcing Fluree, the bulk of it, this quarter. But so right now we're the only ones able to kind of build new consensus models. But we support both Raft and PBFT, which have different sorts of trade-offs depending on what you're looking for. So when you create what we call a network in Fluree, a network is a group of potential databases. Each database is actually its own blockchain, but they share a common set of rules, perhaps a common set of participants, and they will all share the consensus mechanism you set up for that network. The other thing we do, because we designed this to allow us to host it, and we designed it with the idea that other people would want to charge for usage, or perhaps we would evolve to a token economy for transacting and utilizing data in Fluree, is we have a concept we call fuel, and it's a lot like Ethereum gas. Every time you issue a transaction into Fluree, it will go through, it's going to have to touch a bunch of data points, it's going to have to look up your schema. We have what we call smart functions, which is kind of like smart contracts. You can write your own programming logic. All of that has different fuel cost. And so every time you do anything in Fluree, we actually report out to you how much fuel you consumed. Again, identical to Ethereum's gas. So the product's already doing sort of a token economy piece underneath it. However, right now, of course, we allow you to have negative balances. We're just sort of calculating the different participants and how much they're consuming. We allow you to do the same thing on the query side. So we actually calculate fuel for every query, which has some really nice benefits because fuel gives you an indication of how much work a query had. And especially complex analytical queries, oftentimes there's more than one way to structure them. And you can even get real-time feedback as to which queries are more efficient than other queries because we're always reporting out this consumption metric to you. That same consumption metric can be used in the future to actually have a fully public version of Fluree, which, you know, at the point, should we choose to do that, becomes sort of like the world's database.
Okay. So I'm going to address one other question here with maybe some slightly different perspectives. You've got the blockchain element, the decentralized element, you have the immutability, you have permissions modules, you have options of consensus algorithms, you have joins and relational data, you have ACID compliance, RESTful APIs, GraphQL support, the time travel aspect, and of course, scalability, which every database claims. This is a lot of features. So I guess the first pessimistic question is, like, this is a lot of potential positives. Hand on heart, what are the drawbacks? What are the negatives?
Yeah, I'd say the biggest negative, and the one that we're always very upfront about, is that we are not trying to win a transactional volume war in the database space. So different sort of database architectures, especially like a document database, document databases are very weak in their ability to query. Relational is far better, but they're immensely strong on being able to shard and scale. So you're always giving up things in favor of the other. We thought effectively delivered the ability to have to make less of those decisions by actually separating the transaction engine from the query engine. And this is actually one of the reasons, because now query doesn't have to be, anchored by the transaction engine. It can scale independently, and our query servers effectively run as in-memory databases. And in fact, we even have a JavaScript version we have not released yet, but it is our query engine, which you can embed right into a web app or an iPhone app, which is kind of cool. You're actually running a mini blockchain database right inside your app. We even have a version that automatically analyzes your queries, knows what updates would affect any data you're currently looking at, and will automatically stream new data to you, enabling you to build completely real-time applications with zero additional effort as a developer, because the database is just feeding you the data it knows you're looking at, which is kind of cool. So that separating the query engine out is opening up a lot of really cool ideas. And of course, any database I'm sure you've probably ever dealt with doesn't separate these roles out. It's always one server that's doing all these sorts of things. So we're trying to isolate the impact of transactional volume. And that's one of the ways we did it. Now, most enterprise applications are very, very heavy reads and analytical reads and very light writes. But if you wanted to have a database that stored all your log files, or you got a billion IoT devices out there and you're trying to do those, Fluree is not going to be a good choice for that. You want a database that's optimized towards writes and not reads. We're definitely optimized towards reads and not writes.
Okay. And then I guess the reverse question of that, I'd kind of like to know, how long have you been working on this? How long did it take to build?
About 4 years.
Okay.
So we started this project in around 2014.
Okay. And just to understand here, you are mostly going to the enterprise market. There is this community version with 100 megabytes of storage, which is not massive, but depending on your use case, could be enough. 1 million of this daily fuel, which I guess you're borrowing the gas concept, but if we like, for the more traditional developer, we can think of as AWS credits or something like that too, pay a free tier. But is this all hosted, or developers can also download a Docker image, a Homebrew package, a Debian package, whatever it happens to be, for very least for testing and developing? Is that possible?
Yes, and in fact, you can do that for free right on our website, and you don't even have to give an email or anything. You can just download it straight away. It runs as a jar file, a Java. So anything that can run Java can run Fluree, and that's actually how most people are using it today. And we've also got a homebrew recipe. So if you happen to use a Mac, you can install it.
I guess the next best question would be to find out, do you have any current clients / if you can't discuss the client / ideal use cases?
Yeah, so we have a lot of people using the community edition for, their own MVPs and products, of course. And then we have a handful of paying clients. We just released a licensed version in December. So we've really only had that available now for about 3 months. Those early adopters tend to be technology startups themselves. And one of the interesting things is we have 2 projects right now, and because I'm sure they'd appreciate it, I'll bring both of them up. But they're blockchain-based applications that are using Fluree as the foundational pinning. And what's neat about Fluree is you can essentially write your own custom blockchain logic using our smart functions and create your own custom blockchain without having to fork, some other blockchain and start hacking into it. So one of them is Idea Block, which is taking on the patent system, allowing you to submit ideas for little to no money in some cases to prove that you invented something at a certain moment in time. Another is a project that's getting a lot of publicity right now, which is Fabric, which is challenging the advertiser ecosystem and allowing advertisers to pay you directly instead of Facebook selling your data. You can sell your data and actually make that money directly. And these are projects that would have had to build their own custom blockchains and a bunch of stuff to do. And they come across Fluree and they can actually just configure Fluree and start focusing on their unique use cases. So we expect to see more and more of those. And then we have a lot of good examples in the enterprise space where they're looking at niche projects. We just completed a proof of concept for one of the states in India to migrate their government records over to Fluree. And we're actively in discussions because the POC went so well on permanently moving the government records over. So we see some interesting government utility here. So I think a lot of neat use cases, but as you know, the space is early and emerging. So we're definitely thankful for the early adopters.
And I would actually be interested, and whilst I think the space is less busy than it was a couple of years ago, technically speaking, how do you compare to something like BigChain DB?
Yeah, I think, well, for one, I think BigChain DB is a great product. My thought on its optimal use cases is not all that different from most of the other blockchains out there. It's still focused around the idea of a transaction. Of course, they've taken it a step further and allowed you to try and attach more data around that transaction and get a little bit more utility out of it. Something with most of the other blockchains that either it's expensive or you can't really put data in it. You have to go to a completely different data store. But it's still very transactional focused, the core use case they're solving. So we are not transactional focused. You can configure using smart functions, FlureeDB to act like a currency or a transaction engine if you want. But if what you really want to do is just transactional stuff, a product that's optimized for that is probably going to be a better fit. As it relates to Fluree versus BigChain DB being used as a data store itself, I think the differences are probably much larger than the similarities. Our focus is all around our own technology. They sit today on top of MongoDB. We enforce full ACID compliance for the transactions. We're a graph-style database. We offer a lot more query capability. We offer this incredibly cool feature of time travel. We harp on that we've had time travel on our Mac hard drives now for a bunch of years. Even things like Microsoft PowerPoint have time travel now. But none of our business applications do? And you would think that would be way more valuable than any of these other applications of time travel. And again, just by using Fluree DB.
Is it comparable to something like traditional version control? Or, how does that look? Are you maintaining various copies of the data at various points, and that's configurable, I guess?
It's all in how we index data to understand time. And again, I mentioned this is a pretty core component of what we do, and a very difficult component of what we do, because we promise the same speed in your queries at any point in time, whether it's a year ago you're querying the database or a second ago. But it's how we index and lay out the data allows us to move over time very quickly. We make heavy use of what we call functional data structures that allow data sharing. So basically, when we have every version of the database, and say your database is 2 gigabytes, and you've got 10,000 versions, we're not storing 10,000 times 2 gigabytes at all. Everything is just storing the deltas. And how we lay out the indexes, even in disk persistently, all allow us to move over time very, very quickly, but everything is shared. And what's cool about this, like I mentioned, when you issue a query to the database, you're actually issuing a query against an immutable specific version. If you don't specify the version, we'll just grab the last version. But say you're running Fluree on an app server and you got requests coming in, and maybe your requests take a second to process or whatever, and you got 1,000 requests coming in, you can actively run on the same app server. When that request comes in, you grab a version of the database, you treat it like a variable. So every part of your logic has now a guarantee now, which is the data will never change underneath it. And this creates a lot of race conditions in our software as we're passing around, different functions or issuing a query, but the data changed right in between, and now something breaks. Never ever happened with Fluree. But in that scenario, you can have thousands of versions of the same database simultaneously running on the same app server, and you'll maybe see just a 10% memory impact because of that. And that's because of the immense data sharing that's done across all of this. So it's super efficient. And a really cool thing we do, which is a little mind-bending, at least for me, is that in your queries, we're actually querying each part of your query against a potentially different data source. We talked about this. A data source could be Wikidata or could be Fluree. It can actually be many different versions of a single Fluree database that you're querying in the identical query. So you can do joins against, your product set from a year ago, from your product set now in the same database, and find out what's common and what's changed. Like, you can actually do these sorts of things now. It's really cool.
Yeah, that makes a lot of sense. Yeah, it's there's a lot packed in here. It's something I think people definitely need to play with and try and prove or disprove how useful all of this is, I guess. And a lot of people get used to maintaining multiple systems and then having bridges between them. And sometimes that's a good architecture, and sometimes that's more complicated to maintain than it's worth. Whereas you sort of have a lot of it in one place, which obviously is also a single point of failure, but it's interesting to try. And actually, on that question, it's not immediately obvious to me, but I'm guessing that, especially if I was running this myself, it's a cluster style setup.
Yeah, it is. So so even when you're running it internally, we'll run it. There's no reason to run PBFT like that, because PBFT has overhead that Raft doesn't have, and it actually doesn't have the same amount of fault tolerance that Raft has. So we have what we call a transactor group. And a transactor group, or a ledger group, is basically a set of redundant servers you're running yourself. So that group will expose itself to the public network if you're participating with other organizations. If you're not, that's fine. But if you are, it exposes itself as a single identity, or multiple identities if you want. But the group you run has full redundancy. So if a server goes down, you're still participating on the external network. And the other thing, it's not just for redundancy. We actually have built in a mechanism in our internal protocol where it will share work. So if that transactor group is managing 30 databases, it's going to actually start assigning different transactions for different databases. So all the servers are doing work and processing things much faster.
I mean, obviously everything is pretty new right now in terms of the way the product is anyway. But what's on the roadmap for the next 6 months? What features you're looking to add, or events, or milestones that are coming up in the next 6 months or so?
Yeah, well, a big one is we're going to be open sourcing the technology. We feel like we're at a stable place to do that, and our APIs have stabilized. So that's probably the most significant one. We have, from a lot of our users, we have some feature requests of things that they've gotten used to in a lot of today's databases that we don't have, like indexes for geo indexes for. So we want to not only add geo, but still couple it with point-in-time travel capability across these data points. So those are a number of features, and our smart function library is quite expanded now, but certainly as people have different use cases or they're trying to do certain things, we have a whole library of out-of-the-box functions you can take advantage of, and you can write your own functions. But that library of functions is certainly expanded.
How big is the team, out of interest?
The team's about 10 people right now, and of course, over the last 4 years, it's been more than that, and we have had contractors that we've pulled in at different points in time. So the total set of hands that have probably worked on our code base over that time is closer to 20, maybe 25.
Just a very possibly tangential side question. You're in North Carolina, yeah? I think I saw.
Absolutely.
There's a lot of technology companies in that area. Do you have any explanation for that? Why there's so many reasonably well-known technology companies in that area? Is there something that attracts companies there?
Well, there's a area in North Carolina we call the Research Triangle that was set up, I don't know, about 20 or so years ago, and attracted a lot of investment. The city got behind it. They did a lot of things right, and it has continued to produce results to this day. So yeah, we got a lot of big tech companies here. We're certainly not a Silicon Valley, but it's a good place to be.
And that was my slightly poor quality interview with Brian from Fluree. That is another Weekly Squeak wrapped up for the week. If you have enjoyed what you heard, you can find more on christianschiller.com/newsletters or /podcast, depending which version of this you are reading or listening to. I am about to start recording 2 new podcasts very soon, so keep an eye on those spaces, as well as launch a couple of specific topic newsletters also coming soon. So keep an eye on christianschiller.com for all of those. You can also tweet at me at Chris Chinch. I'd love to hear your opinions and your feedback, your ideas. You can do those on any of the channels that this newsletter and podcast go out on. Please rate and review. And if you have been, thank you for listening.